Wow. Let's hear it in Indian accent.
Was it really dope? I can't say it was straightforward.
All right. All right. Yeah, I would say that that is an Indian accent for sure. Hello everyone, welcome back. And today we are gonna look at one of the long form videos again, where I'll walk you through a TTS setup, a text to speech setup. And one of the reasons why we are doing this today is because we eventually want to develop something Jarvis like, where we can talk to the system and the system is able to understand what we are saying, so which means synthesize the speech, convert it into text, and then respond back based on that. Once it has taken an action, then we want the system to respond back to us in a speech format, right? So we want to have that natural language spoken back to us, which is where today's component will come into picture. So this system that we are going to talk about today is called OpenVoice, and we are going to install it on our Dell R730 Linux server, which has two NVIDIA P40 GPUs, and it is an overkill for what we are going to do today. It doesn't need a lot of processing power, but because we are building our a whole lab in this particular server, I wanted to show you how to install OpenVoice over here. And there is something that you will also notice. NVIDIA P40 GPUs have a very unique specific thing that we'll talk about, their computational strength and power when it comes to the default FP16 computation that is missing from P40, and how we will come over that, right? How we will overcome that situation. We'll take a look at that also. So before we dive into it, I want to show you the system configuration over here. So let's just do settings, and I want to show you how this particular system is set up. And we've seen this system setup, this Ubuntu machine setup in our previous video. So this is running on an ESXi, and it is using Xeon E5 2680 V3. 48 cores are in here. Well, there are 24 cores, 48 threads are here, and we have two NVIDIA P40 GPUs in here, right? So we get the full 24 times 248 gigs of VRAM over here, right? So, and to visualize all that, we always run our watch command. Watch every 0.1 second, NVIDIA SMI should refresh. And let's take a look. This is how our two GPUs look like, refreshing every 0.1 second and barely consuming any power right now, just being plugged in. The max power draw is 250 watts, and they both have 24 gigs of VRAM, and almost nothing is being used. What else is running on the system? So let's see, Docker PS, and we already installed Olama and OpenWeb UI. We are not going to use that today, but I just wanted to show you that this is also something that's running in the background. We have not removed, uninstalled anything over here. However, we are going to create some space on this server so that we delete some of the models that we had installed earlier before we proceed, right? So let's start by doing that. So we'll go to our Open Web UI page, which is a localhost 3000 for us, and we'll sign in and just go in and delete some of the models that we don't need, right? So some of these models that are big, huge, space consuming models, and I do not have a ton of space over here. So I'm going to be deleting some of these models just so that I can create some space over here, and we'll leave one of the smaller models to work with and play with later on, or if we need, we can download some of the models also later on. Okay, so we're leaving Mistral latest over here, 5.3.14b instruct. We can leave this too right now, this is fine, and 5.3 a smaller version fine, right? So we have sufficient space on the server now. You may not need to do that if you have enough space. While creating this machine, I did not allocate enough space, so I just want to quick show you my disk usage analysis. we have now 150 gigs of space, which is awesome, right? I mean, more than enough. I noticed that after all these models, I was getting close to like 40 or 50 gigs of space, and I did not want to run into space issues while creating this video. Let's dive into what we are here for today. So we are here for OpenVoice V2, right? That is what we want to install. This is coming from My Shell AI. And this is pretty cool. You know, this was recently released in April 2024, and it includes all the previous features from V1, which they claim to have better audio quality. It is pretty good. Native multilingual support, that's nice too. And this is what I absolutely love, right? That both V2 and V1 are released under MIT license, and they are free for commercial use also, apart from your personal use. So this is pretty cool, right? And it features accurate tone color cloning, and we'll see all that later in the video. Flexible voice style control and zero shot cross-lingual voice cloning. And this is awesome because you don't need to provide it a lengthy amount of audio to learn the voice. It can do it even with a smaller, shorter voice samples. And we'll see all that today too. So in our first install it, they have their detailed instructions over here, right? So in the usage, which is right here, they have the detailed instructions. A Linux install instruction is here, and we'll have to use Linux, and we are going to use V2 version of the instructions. But I would not recommend following their guide. If you follow their guide, chances are this thing will not work for you. So what I'm gonna do is I'm gonna have my own guide over here, which is extracted from their guide obviously, but then I have done mods and tweaks so that I foolproof the whole install process, and I don't leave any loose ends or assume that things are already installed for you, which they probably are assuming. And if you follow their guide, most likely you're gonna run into a lot of issues. All right, so what are we gonna do? We're gonna leave this page open, right? We're not gonna close it. And how did I find this page? I just looked them up on Hugging Face, or you can just Google OpenVoice V2 and you can go to their Hugging Face page, or you can also go to their GitHub page, right? OpenVoice GitHub actually has exact same instructions. So going to GitHub isn't gonna give you a newer detailed instructions. If you think that would save you, they have exactly same data copy pasted on their GitHub page, even the same video over there, and exactly same instructions. So they ask you to go to usage, you click on that, and then it takes you to this particular instructions page, which is exactly that. It's exactly same set of instructions, right? So let's minimize this, go to our own instructions that we have, right? So you're going to need two things before you start the installation process, and those are Cuda and cuDNN. And what are these two things? So Cuda is actually a runtime and driver API that NVIDIA provides you with. And this is what interfaces for writing and managing GPU accelerated applications, right? And in this case, we are going to be using GPU for acceleration over here. I mean, can we use CPU acceleration? Yes, and actually for voice, it is all right. You can still get away by using CPU acceleration, but if you have a GPU, you should make use of that. And this is where Cuda libraries, they come in handy for you. And Cuda provides tools like NVCC, right? NVIDIA's Cuda compiler. And it also provides you with profiling tools like Nsight, and also some debugging tools that you can use. And it also provides you with some samples and documentation once you install Cuda Toolkit. The second thing that you will need is cuDNN, and cuDNN is Cuda Deep Neural Network Library. And I know it's a mouthful, but it is a GPU accelerated library that is specifically designed for deep learning, which is again something that we'll be using today. And it provides a highly optimized implementation for standard deep learning operations, which makes the neural network training operation and inference faster and more efficient, because you'll be using all the Cuda cores and the Cuda development kit along with cuDNN. So these are the two things that will install. And if you do not install it, then most likely your installation for OpenVoice will not work. I mean, not most likely, it will not work. If you do not have NVCC and cuDNN, and if you are trying to use your GPU acceleration, it is not going to work. So step number one, let's see if we have NVCC, right? Our compiler installed. It is not installed. And it says that, hey, if you want to install it, you can install it with this command. So if you just go ahead and install NVIDIA Cuda Toolkit, is that okay? Maybe it is. Maybe you can just run this and it's okay. And how do you know that? You can first see what version of NVIDIA Cuda Toolkit is going to be installed, right? So you can do an apt show command, and you can see if you do run sudo apt install NVIDIA Cuda Toolkit, what is it actually going to install, right? So if you run this, it shows you that it is going to install your 11.5.1 version of Cuda. And if you look around, and I happen to know that 11.5.1 is compatible with our driver version over here, 535. So there is a driver compatibility matrix, and it talks about all that, and I've done my research over here. So you are good with 11.5.1 version of NVIDIA Cuda Toolkit. And for 11.5.1 version, you will need the cuDNN version of 8, because that is what is being used in the OpenVoice V2, right? And in the Melo TTS that will install. So if you follow the guide that I'm providing over here, everything will work seamlessly for you. And I've already validated these steps so that things are not harder for you and things become easier for you. All right, so this is the version that we're going to install. So that sudo command is all right. We can go ahead and install it. We don't want to just blindly copy paste commands. We want to do our research too. So that's why I wanted to show you this. We are installing our NVIDIA Cuda Toolkit now. And once this toolkit is installed, we'll double check our NVCC version, which should then say 11.5 for us. So let's wait for a little bit. Let's have this Cuda Toolkit install. So it will take a little bit of time, and there's a lot of downloading that's going to be done today. So be prepared for a lot of internet bandwidth to be used. So I got, again, like I mentioned in my last video, I have this gigabyte up and down. So a lot of these processes are way faster for me. If it is taking longer for you, just know that that is expected. It will take some time to install these things. Not only that, they are bigger packages, they will require a lot of processing power, and definitely it will require a lot of downloading time from the internet if you have a slower internet connection. So I'll wait for this to get installed, and while it is installing, let's take a look at the next steps over here. So once we'll have our Cuda Toolkit installed, we'll validate the version. I mean, we already checked our apt show command, so it should show 11.5, but we'll validate that. And after that, we'll move on to our cuDNN. So, okay, so this is installed. Let's validate our version again. And we want to see 11.5 over here, which is good. Very cool. So step number 2, we need to now download cuDNN. And how do you do that? So you can either go online and you can just search for cuDNN download, right? And once you go over here, it will take you to this NVIDIA's website, developer.nvidia.com cuDNN. You click on that, and you will be taken to the cuDNN page. You can close out of this. Download the cuDNN library. You can click on that. And but you see, it's taking you to 911 version. We do not want this version. We want version 8. So we will not be choosing our operating system over here, but we'll be going to archive of previous releases over here, and we'll be choosing version 8. So not 9, not 9.0, not 9.1. We'll go over here and we will pick Cuda 11 compatible 8 version, right? Why are we doing this? Because let's go back over here. Our NVCC version, our Cuda version is 11. So we want to have version 11 compatible cuDNN, right? So there are two versions. So cuDNN has various versions. The version that we want is version 8 and not version 9, and I'll explain this later in the video, but you want version 8, and version 8 has Cuda 12 compatibility and 11 compatibility. You want the version 11 compatible Cuda and cuDNN version 8, right? So this is the download that we want. I cannot focus more on the statement. This is the download that you want. And the best thing to do is to get the local installer for Linux. When you click on this, it will ask you to sign up, right? So, I mean, if you have an NVIDIA account, I happen to have it. So I'm just going to use my NVIDIA account over here, and I'll just sign in. And yeah, it's gonna ask me to just do the security validation on my email, and if I click yes, it will be all right. I'm closing that window because I have already downloaded that. So I already have this particular cuDNN version, right? So if you see, it's the exact same version 8.9.7 for Cuda 11, right? This is the version that we want. I've already downloaded it, but this is the location I want to show you, that you have to go to archive of previous releases and download the version 8, which is compatible with Cuda 11. All right, now that has been said and done, let's go to my instructions back and let's see what are the next steps. So we need to first make sure that this library exists. So if you are starting from scratch, most likely that library does not exist, right? So you're gonna have to, well, if you want to double check, you can quick do ls for this, and it will say there is no such file or directory. It does not exist. So let's just copy this and create that folder over here, right? So now if you run that again, it will say that that folder is empty, and that's why it did not give you no such file or directory error anymore, right? So you have your folder created. Step 2, let's go and download this archive. Well, we have downloaded it already, so we have to go and extract this archive. You can do it with a command line, or while we are here, let me just right click and extract here, and it will give us a visual, representation. So let's just see. It should create a Cuda folder with a cuDNN folder or Cuda folder in a way, and have the libraries that are required for deep neural network. So let's just give it a few seconds and it should start extracting it soon. Yep, so one of these processors is running high. So this is probably the one allocated to the zip, and it is working. Preparing to extract. So I'll just wait for a little bit more. So it is gonna be extracting soon. And once it is done extracting, let's take a look at the steps so that we know what we have to do next. So once the extraction is done, what we'll do is we'll cd into that particular folder, and then we'll just copy the files from this folder into our USR local Cuda folder, right? So into the include and the lib, in these two folders, we'll start copying. So, okay, perfect. So this is starting the extraction process, and pretty slow extraction, I would say. I mean, it's running on a SSD. I should expect a faster extraction. Maybe there are a lot of smaller files in here. So in lib, not even that. Interesting. Not a lot of small files, but still extraction is not as fast as I would have hoped. All right, so this extraction is happening over here, and I'll let it finish extracting. And once we are done extracting, we are already in this particular folder. I can right click, open in terminal, or I can just do a CD into that particular folder, right? So okay, so it says that it is extracted over here now. I can do a CD download. Okay, and then I think our Cuda folder over here, right? So if we see, we have our include and lib. These are the two things that need to be moved over to our USR local folder now, right? So USR local. So these two commands are gonna move your library files to where they belong. So let's move the first one, paste, right? Oh, we have to create the include directory also. This include directory is in there. Okay, all right. So let's do a, where is our mkdir command? Over here, and paste, and let's do a / include, and we can also do a / what was the second one? Lib. So let's create these two folders, and then the files will be copied over in these folders. Right, so let's get out of here. Now let's copy this first set of files into the include. So we are saying copy include / to include over here, right? So that is done. And let's copy the second set of files. Copy from here. I think it is lib cuDNN * to Cuda lib. Okay, yep, perfect. That's right. Okay, and let's copy that. It will take a little while. I think these are the bigger files, so it will take maybe a few seconds, and it is copied. So let's do a quick look into this particular folder, or not CD but ls, and let's do ls/la. And this is what we want to see. So you see that all of your Cuda libs are cuDNN libs are in the right folder over here now. And this is extremely important, because this version, if you do not install Cuda and follow the OpenVoice guide, this is what it will complain about, that there is an .so.8 files that are missing from this particular folder over here. So we are golden over here now. We have installed this. We have to just add these things to a library path, and let's do that next. So we are gonna open this particular file, cuDNN.conf, and we are just going to add this line to this file, right? And Control X, Y, enter, and then we are going to save and exit, which is what I did. And if you want to see the contents of this file now, you can just do that again, just to see the contents. This is the file that is there now, because I have already added this over there, and update the library cache. Let's run this command, and library cache has been updated now. Okay, we are not done with the cuDNN configuration yet. We are going to add this to our etc environment variable also. So we'll open this, and I'm hitting end and enter to get to the new line over here. And I'm just gonna copy this particular line and paste it over here. Control X, Y, enter, right? So now this particular environment file is also updated. And on top of it, well, yeah, we'll reload this. So we're gonna reload that file. We're also going to add it to bash rc. so that anytime when we open a new terminal, it is available over there for us. So bash rc is in our home folder. Let's edit our bash rc file, going all the way at the bottom, and all right, at the bottom over here now, and we're gonna just add this particular line in our file to Control X, Y, enter, and that is updated. So your cuDNN and your Cuda drivers and everything else is in place now, right? And we're gonna source this so that it gets reloaded and refreshed. Okay, so now all that is in there. You will need to install ffmpeg also, and if you don't, then you will get this particular error, no such file directory or ffprobe. So ffprobe gets installed with ffmpeg, and let's install this also while we are here with sudo apt command. So in terms of our steps, we are done with Cuda drivers, we are done with cuDNN, and then now we are doing ffmpeg, because this is something that will be needed also during the voice conversion. So we are just gonna use the app to install that, and about done. Yeah, with that. Okay, and so when you're running these commands, right, it doesn't matter which folder you are in. So don't worry if you're in this archive folder, because your apt doesn't care which folder you are in. Okay, now the things that I mentioned over here, these things we'll talk about after we are done installing OpenVoice with their regular, install instructions, right? So this is the Linux install instructions for OpenVoice now. So what you're going to do is you'll have to go back to their Git repo. So now your operating system is set up to install OpenVoice, and these are the instructions that are missing from their documentation. So if you are, maybe they assume that it's all these things are set up in your machine, wasn't on mine. So I want to be very thorough that while you're setting up from scratch, these are things that you will need. Okay, I'm gonna close this NVIDIA page, go back over here, and now what you want to do is you want to clone this repo. And in order for you to clone this, you'll come over here, go to code, and just copy this HTTPS URL, right? So just copy that, and you can, now it matters which folder you are in, right? So cd, right? And let's go back to the home folder and then do, I think Python projects is where I was keeping my stuff. So let's do cd Python projects, and this is where I would like to clone our repo. So git clone, and then you can paste this link. And when you hit enter, there will be a new folder called OpenVoice inside Python projects folder, where you will have your git repo cloned, right? Okay, so git repo is here. And if you do lsla, you will see a new OpenVoice folder created. Let's cd into it, and let's see what's in there, right? So we have all the OpenVoice related data from their Git repository cloned in our local machine now, right? So you'll see there is a setup.py. Maybe you can already figure out what's going to happen next. We are going to use our pip install -e dot option so that we can utilize the setup.py. So if you do a cat for setup, you can see that these are the libraries that are required, and it will go in, it will look at all these dependencies, install it, and also configure it for you to use OpenVoice in your packages, right? So before you do that though, you'll first need to switch to a new Conda environment. Conda, we have already installed it in our previous video while we were setting up this server. So I'm not making an assumption that you have it installed on your machine, but if you do not, please watch the previous video where this server was being set up in the Dual P40 format, and we had installed Conda over there. So because we already have Conda installed, we can now make use of some of the commands that are available over here. So the command that we have is conda create -n, which is for new environment, OpenVoice Python 3.9. So this will create a new Conda environment with Python 3.9, which is what they use, right? So we'll create a new environment, which will take a few seconds. All right, and once it's ready, it's asking me, do you want to do that? I'm gonna say yes, and then it is going to create this environment, and then we'll have to activate this environment too, right? So Conda activate OpenVoice activates our environment. Once we run this, you will see the base changes to OpenVoice over here, which is what we want. So we have a new Conda environment called OpenVoice available to us, right? So let's do a clear, let's start with a fresh screen and let's go to the next steps. We have already activated the environment and we have already cloned the repo actually. So we are good with that too. And we are already inside the OpenVoice folder, right? So we have done with all that. We have seen that there is a setup.py file and we can install OpenVoice over here with this command now. So pip install -e will take a look at that setup file and it will download all the dependencies that were mentioned in that setup file. And this is going to take some time. So be prepared, bring, like a coffee or something, and be prepared to wait and watch for a little bit, because depending on your network speed and your processor speed, like I've said, sound like a broken record at this time, but it is going to take time depending on all the different configuration parameters on your system. So over here, I can see that on this particular machine, it is not a lot resource intensive, but definitely it is receiving files at a slower rate than normal. So this is not my network speed. This is just from where it is getting it from. It is just downloading at a lower speed. So I'll let it download and I'll let it run. And we'll just wait for a little bit while this is getting processed over here. So what is next? While this is getting downloaded, what is next? So next is we have to install MeloTTS, and we can do the same thing for MeloTTS too. What is MeloTTS? Let's take a look at that. So if we go back to the same repo from where we got OpenVoice, right? I'm just doing a filler while this is being downloaded and installed. So let's talk about some other things meanwhile. So MyShell AI also has another project called MeloTTS, and MeloTTS you can again download and you can again install, and you can see there's a setup.py over here too. So you can again have your MeloTTS installed just like pip install -e command, and that will also be available to you. And maybe that's one of the ways to do that. But they provide to you various different ways in which you can install MeloTTS. The way that they have mentioned on their documentation is to let's see. They have mentioned the Git way to install it, right? So what does this mean? Pip install git plus and providing the GitHub link for MeloTTS. What this does, excuse me, this actually clones it in a temporary location, and then it runs your pip install -e command in that temporary location, and then it removes that. So if you install it this way, you won't even see your the folder for MeloTTS, but it will do exact same thing. So you have two options now. You can do a git clone, and then you can install it, and then you can use it that way, or you can just run the commands that they have provided, and you can install it that way too. So let's see. So this is still working. This is still working. And this will work for a little while too. So while this is working, what else can we talk about? So let's take a look. Yeah, I haven't tried this on Windows or Docker or any other system apart from Linux. So I can only answer questions about Linux at this point of time, but I would believe that the process should be very similar. I mean, if they have provided us a Docker way of doing it, then then this should be very similar, straightforward process from the Docker's point of view. All right, things are getting downloaded. Oh, no. Okay, all right. Let me see if I'm running into disk space issues over here and what I can do to fix that. Just a moment, please. All right, so I had a temporary glitch over here. The machine that I have, the virtual machine, I had multiple snapshots taken, and because of that it was running out of disk space. So what I did is I deleted some snapshots, and hopefully I will not run out of disk space issues over here now. I ran that command. It continued from where it had left off, and I can see it downloaded rest of the stuff. So I think this is somewhere where we were. It continued downloading from there, and it is I do not know if it is done yet. It is still processing. Oh, it is actually done now. Okay, so our last command, which was pip install.e -e dot, is finished now, and let's take a look at our next command that we have. Right, so over here now we have to download checkpoints underscore v2 folder, right? So we want to run the OpenVoice V2, and we have to download the checkpoints v2 folder. And where do you find this? All of this is in their documentation too. So we are kind of just following their documentation from here on. So their v2 documentation. Right, so we created a Cuda environment, activated that, cloned the repo, went into the folder, and we are done with pip install.e now, which is what you see over here too. Right, and we're not going to follow their v1 instructions, but we're going to go to their v2 instructions and we'll follow that. So now it's the same instructions that you see. You can download this particular checkpoints v2. I have already done that. So if I go to my downloads folder, I already have this checkpoints v2 folder, right? So let's just delete this that thing, and let me just extract this over here, checkpoints v2, right? And it is extracted, and what they're asking is that this is the checkpoints v2 folder within which you have base, speaker, converter, and all that, right? So this is the checkpoints v2 folder. Cut this out and put it into your OpenVoice folder, right? So at this level, right? So right where you have the git, you have to put it that level. So you will see setup.py, these 3 demo files and stuff, and at the same level you have to put your checkpoints v2, and inside checkpoints you have base, speaker, and converter, these 2 things, right? So that's what you have to do. And once you are done with that, now you have to install MeloTTS. And then, like I said, there are 2 approaches over here. You can do a direct install like how they are recommending to do, and that's fine too. Maybe we'll just follow this approach over here, where it will download it to a temporary location, and then it will delete it for us, and it will perform the installation for us too. If you did not want to go with this approach, but you wanted the MeloTTS in your local folder, then what you could have done is you could have just done a git clone of that, went into that, and then just done a pip install -e dot, just like you did for your OpenVoice, right? But either way, either you do this or you do this, you can then come back in and you can download the additional dependencies after you have your MeloTTS installed. So let's wait for a little bit over here for this process to finish. Should not take much time, but let's wait and see how much more is required for this process to finish. But once we are done with this, excuse me, what we'll do is we'll open, we'll have to download this unit from here, but let's also, excuse me, open our Visual Studio Code while all this is being done. So in our Visual Studio Code, because we were using the dev containers last time around, it is trying to start the dev container. So I'll let it start, and then I will close the remote connection. I don't want to interrupt this process while it is starting. So we were doing some crew AI based work last time around, and okay, that is here. And let me just go in and just close remote connection so that we are out of the dev container setup, right? Okay, and oh wow, so this is done. We can run the unit command now over here, but before we run this, I can just do a code start. So our code opens into this folder. Oh, we have two instances now. We can close out the one that is empty that we were opening earlier. So this is good. And meanwhile, in the back, we can just paste our downloading Unidic additional dependencies over here and hit enter. So this is, I think, about 500 megs if I'm not wrong. Yeah, and it takes some time to download too. So let this run in the background as well. All right, while this is getting downloaded, we can allow that. And while that is getting downloaded, you can just take a look. So if you saw, what I did over here is I allowed this environment to be Conda's OpenVoice environment. If you do not have that, just take a look. If it says something else except for OpenVoice Conda, you can just click over here and you can choose your Conda environment, right? You can choose this environment over here too, which is the same thing that it did at the start. It was asking me if it's okay to do that. So while we were running our git pip install -e, this is what was being executed from setup.py, right? So it was checking for Python version and stuff and installing libraries. And this is where somewhere over here it noticed that I do not have disk space, and then I had to restart this process. But you shouldn't be having that issue if you have enough disk space. All right, so our installation is still going. Not too excited about the speeds that I'm getting from this repo, wherever it is getting it from. It is not very fast, but it is gonna get done. And once this is done, we are actually, believe it or not, done with our installation of OpenVoice. What is next then? So I'll minimize this, or let's just open the other tab. Okay, so now what they recommend is to go to this particular demo and just run this, right? So for us to do that, let me just show you this particular notebook. Okay, so in the notebook, they have all these details over here, right? Like import, do some imports, and then configure some of the attributes and parameters. I've just extracted this notebook out and just put it into a nice Python program for us over here. And I've also added some comments for easy understanding, and I'll do this commentary after I paste this in my Visual Studio Code project. So let me just create a fresh file, a new file over here. And no, not in this folder. I want it at the OpenVoice level over here. So over here, yep, that's fine. Maybe it was creating over here anyway. So test OpenVoice v2.py, right? So we'll do this and we'll paste this over here. So the same Python script, you can use the one that they have to. It's just that the one that I am showing you over here has some more commentary added on from my side. All right, I just want to make sure, oh yeah, everything is done. And even though everything is done downloading, when you execute the script for the first time, there will be more things that will be required to download, right? So and I want to show you, we are almost done, but there will be one issue that you will encounter, and we will fix it when we encounter that. And that issue is your Whisper model using float 16 FP16 execution. And I'll show you where you will encounter this issue if you do, but maybe a lot of you guys do not have to do that if you're running it on a consumer grade processor, so like 3090s and all that will be fine. You will not need to make that fix that I'm going to talk about if you're running a consumer grade newer hardware, right? So let me now, so I'm making sure I'm in the right Conda environment, and I'm going to run Python test OpenVoice V2 Pi, right? And we will see the float FP16 error over here in our case, but I want to show you that we will see it. So let's run this and let's see what we get over here. And while it is running, it'll do a few downloads, and it will work with some of the things in the background over here, and that's all right. That's expected. You see there's a 1.5 gigs of model file that it's getting, and that's all right. That's all expected. And while it is doing some of these processes, I can quick talk about what is happening. Okay. See, there we go. So I didn't have to explain other things and do the filler over here because this is the error that I wanted to show you. So there is an error which says that, hey, your target device, you want to use your GPU, fine, but your target device does not support float 16 compute type, and you'll have to change that. And if you look around and try to change that in your program, there is no way you can find a configuration to change that value, right? So that value actually needs to be changed when you are creating this model over here, but you cannot change that value anywhere as a configuration parameter that can be passed on, or at least I did not find it, right? So what do you need to do then? There is actually an SES file configuration which is inside seextractor.py. So this is the Python file where they have defined this Whisper model, right? So this particular and I've documented how it was found. So if you want to take a look, there was a GitHub issue for faster Whisper where this has been documented, and I'll just click on this link. So if you want, you can take a look at this link and you can read at your pace later on. But this is a faster Whisper dependency, which is being kind of carried on in this particular project structure over here. And ideally, they should have let us, when they are creating this particular method, they should have let us choose which kind of GPU we want to run it on, right? So model size medium, run on GPU with FP16, and this is the method that is going in and running that particular model. But we do not want it hard-coded to be run always on FP16. This is where we can either change it to float 32 or int 8. So let's change it to int 8, and that should be fine for us to run this particular Whisper model. We can also change it to float 32, and that will be fine for us too. So our hardware P42 supports int 8 and float 32, right? So I'm gonna save this and I will rerun this command, so we'll get past that error. And while we get past that error, I'll show you a couple other things that are happening in our project over here. So you see that there is an outputs v2 folder that has been created, and this is where your final voice will be saved. So let's talk about this particular, let me close this SE extractor. Let's talk about this test Python program that we are running, right? So imports, fine, we have all the imports on the top. We are having a checkpoint converter directory. So remember, we extracted the checkpoints v2 into the converter folder. This is where it is getting it from. So it is saying that, hey, the base speakers and SES are right here. and it is saying if you have a device. So CUDA 0 is what it is using. See, it's already outputting the voice models over here. Let's take a look at our thing. So it is already outputting the voice model, and I'll talk about this too. So let's go back to the Python file. So we have our checkpoints converter. We talked about device CUDA 0. If it exists, it wants to use your GPU over here, right? So CUDA 0 meaning it used our and let's go to the watch command again. So it used our first GPU, right? So CUDA 0, this is the GPU which it used to do the inference over here. So, but if it did not have any GPU, it would have used the CPU for us. In our case, it was the first GPU that it is using. The output directory is outputs V2. And you can see that outputs V2 was empty earlier, and now it is populated with all these data, right? These wave files that have been created. And then it is the program then talks about the tone color converter configurations, right? So how do you want to have your tone color? All that is in this checkpoint converter config file. So in checkpoint V2 converter, there is a config file over here, and you can configure your tone color in this particular file. And I haven't messed around with this, but I'm just using everything default to get us through the default setup over here. And then again, this is the checkpoint PTH file that we downloaded for our tone color. This is the base that we are using, and we are making some directories, right? So we are making an output directory, which is the outputs V2, right? So this is the directory that has been created, and our folders, our final files have been saved over here. Then we obtain the tone color embedding, right? So reference speaker is in resources, example reference. So if I close this open output for now, open the resources, this is the example reference, right? So let's open this in our OpenVoice resources, and you will see, I'm gonna make it like this. So you'll see there are demo speakers and an example reference, and you can choose any one of these to do the one shot training, right? So if I click on this.
When I was a wanted man, the resistance gave me a lot of help. The time I spent with Guru was brief, but he left a deep impression on me. He's the type of person who says whatever's on his mind.
That is the person's reference voice that is being used right now, right? So in order for us to train, we are using that reference voice. And this is then getting passed into the SE extractor, right? So if you see, we modified that SE extractor, right, to get SE, and this is where our configuration was also in the SE extractor. And then we have these texts that we want the TTS system to speak, right? So did you ever hear a folk tale about giant turtle, right? And this is in the English newest. And if you do just EN, then you will see that there will be multiple outputs that will be created. So if you do EN, it creates for Australian accent, BR, default, Indian, and this newest is this particular one, and then US also. So 1, 2, 3, 4, 5 of them are generated by just having this EN over here, and the English newest is corresponding to this particular one. So let's hear them out, that what was the output response that we got. So English newest is what I'll play first.
Did you ever hear a folk tale about a giant turtle?
Sounds very similar, sounds creepily similar to the voice that it was trying to clone over there. And let's hear the same thing in different accents.
Did you ever hear a folk tale about a giant turtle?
All right, pretty good. Let's hear in Brazilian accent, I think. BR. I'm having some audio issues over there. Yep, my hardware isn't working, looks like. Yeah, so this is connected over the VMware. Let's try to see if it's a hardware issue, or probably some kind of...
Did you ever hear a folk tale about a giant turtle?
All right, so something got messed up while generating those two voices. Let's hear in India.
Did you ever hear a folk tale about the giant turtle?
All right, so that works. For some reason, the BR
Did you ever hear a folk tale about a giant turtle?
Okay, it's working now. So something got messed up in my audio player.
Did you ever hear a folk tale about a giant turtle?
Okay, all right. So we got all the different options and
Did you ever hear a folk
voices.
tale about a giant turtle?
Perfect. Now let's do a quick thing over here. Let's change two things. One, I will change this to installing OpenVoice was fun, right? And we'll also do, was it really though? Can't say it was straightforward, right? So let's do these two changes over here and installing. And we also want to change the reference speaker. So reference speaker earlier was example reference MP3. Let's change it to demo speaker 0. Let's first hear what demo speaker 0 sounds like. Let's go to their resources folder, demo speaker 0.
Have you become expert in the deep learning algorithms? Have you learned the state of the art? Have you had deep technical knowledge?
All right, so it is a decent enough male voice over here. So let's have the demo speaker 3. I'm gonna copy this along with the extension, and then I'll replace the demo speaker over here, right? So instead of example reference, I want the demo speaker over here. I'll also clear out the outputs folder so that we start from a blank slate. All right, so let's clear out, empty all that trash, and let's rerun the program. So I'm gonna clear this and we'll rerun the program. Now you'll notice that it takes a lot of time because it's loading the model also. So if I go back over here to NVIDIA SMI, you will see that it is spending a lot of time in loading the model and doing a lot of trivial prerequisites before it actually gets a chance to do the conversion, right? So now it's doing the conversion, and the actual conversion time, it was only like 4 seconds, right? So 4 seconds, 5 seconds, 6 seconds was an actual conversion time. But 6 per second. Okay, all right. So maybe it is even faster. So let's take a look. Over here, let's hear the first newest. Yeah, this one.
Installing OpenVoice was fun.
Okay, yeah. Installing OpenVoice was fun. And the other ones were saying something else. Let's see this. Was it
really though? I can't say it was straightforward.
Wow. Let's hear it in Indian accent.
Was it really dope? I can't say it was straightforward.
All right. Yeah, I would say that is an Indian accent for sure. Let's play it again.
Was it really dope? I can't say it was straightforward.
Man, all right. Okay, I'll just stop. So Australian accent.
Was it really though? I can't say it was straightforward.
Okay, all right. So we were successful over here. So now what happens from here is that we'll make a API, and in that API what we'll do is we'll have all the loading part of the model and stuff done in the GPU always, right? So in the API, we'll just expose an endpoint where we will send a text through the API to this particular OpenVoice server that we create. And then we'll get a response back over the API so that it can be heard back, right? So what we'll do is we'll make this whole thing modular in such a way that there'll be an API layer on top of it, and we'll interact with this OpenVoice server via a Python fast API or something we'll use over here, Django or fast API. I haven't decided yet, and then we'll develop on top of it from there. Well, this is the end of today's video. Thank you very much for watching. And if you have any questions, any comments, please ask in the comment section and I will do my best to respond back. Thank you so much.